Hi everyone, we are from SKE 3533 Communication Principle Course, Session 2, Group 11. My name is Ang Yiqing and welcome to our presentation. Today our topic is Amplitude Modulation AM. Before we start to explain our topic, let me introduce our group members. First is me, Ang Yiqing, second Franklin, third Muiling, and last Imar Degmir. Both of us will contribute to this presentation. Now we will try to explain all types of generator. First, double sideband full carry, DSBFC, is the standard form of amplitude modulation and widely used in commercial radio broadcasting. In this technique, the carrier signal as well as both the upper and lower sidebands are transmitted together. However, a major disadvantage of the SBFC is that a large portion of the transmitted power is wasted on the carrier, which does not carry any information. Despite this drawback, the SBFC remains popular due to its simplicity and reliability. For double sideband full carrier modulation, the AM signal can be explained using mathematical expression. First, the carrier signal and the message signal are expressed in sinusoidal form. When the message signal is applied to the carrier, the amplitude of the carrier varies according to the message signal. By applying trigonometry identities, the final AM signal can be represented as a combination of three components: the carrier component, the upper sideband component, and the lower sideband component.
Next, we have the double sideband suppressed carrier, the SPSC. In the standard AM, 2/3 of the power is wasted in the carrier, so we remove it to save power. This leaves only the upper and the lower sideband, which contains all the actual information. This is the block diagram to generate the SPSC modulated signal. Besides that, we also can generate this signal through two ways: the direct method and use the balance modulator, and indirect method that uses two AM modulator. Same as the SPFC, the double sideband suppressed carrier can be explained by the mathematical equation. First, we substitute the modulating signal into the carrier equation. Then, by applying a trigonometry identity, we rearrange the equation to reveal the final stage. That is a combination of the lower sideband LSB and the upper sideband USB.
Now, let us enter the receiver part. For double sideband full carrier, we use an envelope detector. This simple circuit consists of a diode, a low-pass filter, a DC blocker. At stage A, we have our modulator input signal. At B, the diode reflects it, cutting off the negative half. At C, the low-pass filter smooths the high-frequency ripple to track the message envelope. Finally, at D, the DC blocker removes the carrier offset, leaving us with original message signal. This is how we recover our data at the receiver.
For the SBFC, to recover the original message, we use a synchronous detector. This requires a local oscillator to generate local carrier that has the same frequency and phase as the transmitter. After passing the signal through a low-pass filter that filters high-frequency component, we successfully recover the original message, which is half empty. For the demodulation of DSBSC, an envelope detector cannot be used for DSBSC because the missing carrier causes the signal phase to fade at zero closing, which distort the envelope and prevent the diode from correctly tracking the original message.
In conclusion, amplitude modulation is a basic and important communication technique where the amplitude of the carrier signal is varied according to the message signal. Although modern systems now use advanced digital modulation methods, AM still remains essential for understanding the fundamentals of communication system and signal transmission. Before we end this presentation, we would greatly appreciate your support. Since this is a community education video, we kindly invite you to fill in the Google form provided. Your feedback is very valuable to us and will help us improve our content and presentation. Thank you for watching, and we hope this video is informative and helpful for you.